Hi everyone, I'm Sena Nur Karabekiroğlu. I'm research assistant at Yıldız Technical University. Today I'm gonna talk about my study, and in my study the effect of microwave output power on drying, rehydration and fermentation kinetics and biomass increase of kefir grains were examined. You can see my table of contents. And let's start with introduction. And first, what is kefir? Kefir is a fermented dairy product with a slightly acidic sour taste and distinctive aroma by the presence of variable microflora in the matrix system known as kefir grain. And kefir grains are small, gelatinous, yellowish in color and appear irregularly. And it has the appearance of miniature cauliflower varying in diameter from 2 mm to 6 mm. Kefir grains are valuable starter cultures. Kefir grain consists of a complex flora with protein and polysaccharide qualities, and the grain's chemical composition contains 90% water. Due to metabolic activity of bacteria and yeast in the kefir grain, lactic acid and alcohol fermentation occur together. You can see on table 1 the microorganisms in the natural flora of kefir. The diversity of microorganisms in kefir grains varies according to the type of milk, fermentation temperature, the origin of the grains, and processing conditions. There are a lot of methods for preserving the foods: physical, chemical, and biological methods, and drying is the physical preservation methods. I want to mention about the most effective and the oldest methods used to extend the shelf life of foodstuff is drying. And drying is the process of removing water from solids in order to prevent microbial growth and chemical reactions that may cause food spoilage. Convective drying, vacuum drying, freeze drying, and microwave drying are among the most used methods for drying foods. In the drying of cultures containing leaf bacteria and yeast, the culture can become active again and fulfill their functions after the drying process. Is the most important point for drying process. And literature, there are a lot of methods using for drying of kefirs. For example, the Papostol used the 3 thermal drying methods: conventional, vacuum, and convective, and the Condyles used the freeze drying, and Go used the spray drying, and in my study I used the microwave drying, and I investigated to examine the effects on drying kinetics, rehydration of dried biomass, kefir biomass increasing, and fermentation kinetics. Let's continue with methodology. Actually, for methodology we have the 4 steps. First, the kefir grain graft. Kefir grains were inoculated into 3% fat cow milk and left to ferment for 24 hours at room temperature. And the successive fermentation process continued until the kefir culture was obtained in the amount that the drying experiments could achieve. And before the drying experiments, the initial moisture contents were calculated, and I found it 6.69 kg per kilogram dB. And drying of kefir grains was carried out in a household microwave oven microwave technique, and for the drying experiments the 3 different samples in the form of 10 grams were prepared, and the samples were dried at a microwave oven at 100, 180 and 300 watts. In order to determine the moisture content of the samples, using the equation 1, you can see between the phrases, and for the drying calculation I used the second equation. And after drying, in order to examine the effect of drying techniques and the parameters on the rehydration of kefir culture, samples of equal weight which were dried different microwave powers were placed in 100 ml of distilled water at a constant temperature of 30 degrees and subjected to rehydration process, of course. And during the rehydration process the samples were weighted at a certain time intervals, and the amount of water they observed was determined. And the rehydration rate of the samples calculated using equation 3. And after the rehydration process was completed, kefir grains were inoculated into milk and incubated for 24 hours at room conditions. At the end of the incubations, They were inoculated into fresh milk again and left to incubate under the same condition. And this process was repeated until gas bubbles appeared in the milk. And what is our results? Results and discussion. You can see the moisture rate and the drying rates graphics. Figure 5 and Figure 6 and Figure 7 and Figure 8 radiation rate and the biomass increasing graphics. And the last ones, you can see the kefir fermentation graphics for first day, the second day, 6th day, and on the 10th day. And I will talk about the conclusions on my graph. And firstly, it's observed that the drying times decrease significantly with the increase of microwave power. By increasing the microwave power from 100 watt to 300 watt, the drying times was reduced by approximately 65%. You can see on figure 5. And for second, you can see the variation of drying rates of kefir samples dried at 100, 180 and 300 watts microwave output power with time and moisture contents. And when the figure is examined, it's seen that the initial drying rates are higher at high microwave powers and that the drying process of kefir grains exhibits a drying period at a decreasing rate with the decrease in moisture content at all microwave powers. And if you see the figure 7, you can see the radiation rate to time as a minute, and the obtained results show that the radiation process is completed in approximately 4 hours for all samples dried at different microwave powers. It was determined that kefir grains dried could reabsorb approximately 37%, 42% and 32% of the water they contained before drying respectively. This situation can be interpreted as an indicator of the change in the structure of kefir grains during the drying processes. Equilibrium rehydration capacity values can be increased by increasing the rehydration temperature. You can see on figure 8 the kefir mass to time as a day. When the results are examined, it's seen that the kefir masses are activated and the biomass values increase over time. When the biomass increases of the kefir samples dried at different microwave powers are compared with the biomass increase of the untreated kefir sample, it's seen that the activity of the kefir cultures after the drying process is affected, and the biomass increase rates are significantly lower than the raw kefir sample, of course. And at the end of the 10th day, 100% biomass increase was obtained for the raw kefir sample, and followed by 32%, 19% and 10% biomass increase rates respectively. And kefir is dried at 100, 108 and 300 watt microwave power values. And the last one, you can see the kefir fermentation graphics. And when the results are obtained or examined, it's seen that the fermentation rates are very close to each other. But the fermentation is faster for the raw kefir samples with little difference on the 10th day, followed by the fermentation performed with 100, 108 and 300 watts dried kefir cultures respectively. And the kinetic modeling and the analytical calculations will be done in the next days, I hope. You can see my references, and thank you for your attention. Do you have any questions?